Alright, so on this lesson, guys, we are doing lesson 7.4, which is dilation. Whenever we're talking about dilation in this case, guys, we're actually talking about a point in this case or an object that is actually either going to become bigger or smaller depending on the scale factor. So if we have an object like this, it could actually become bigger or it could even become smaller. Alright, so dilation in this case, once again, talks about sizing as shape. And in this case, guys, it's going to be based off a certain point. So if, for example, let's say they want us to dilate a point or a shape that is somewhere over here, then almost everything will actually be growing. But if I have, for example, a point in this case where it's on the object, then only the section that isn't touching the object is going to be growing here. So let's go ahead and get started here with the formula. Now in the formula, guys, it talks about the length of the image over the length of the source. What this is talking about is that the length of the image actually talks about the new shape, the new form, and the length of the source talks about the old form in this case. So this is the original one, basically, original one that's given. Most of the time, this is if we're talking about, for example, a point, it's going to be A. And the new one in this case, it's mostly expressed as A prime, not necessarily just A, but it could also be a shape like A prime, B prime, C prime. But in this case, the prime goes on top. The regular variable, we want to say letter here, is going to go on the bottom. And scale factor in this case talks about how much it's going to be growing or shrinking. So then in this case, that's just really based on what we're given here. So let's go ahead and get started here with example 1. And in this case, guys, example 1, it says pentagon A prime, B prime, C prime, D prime, E prime is the image of pentagon A, B, C, D, E under a dilation with the scale factor of 1/2. Now, in this case, they're giving us our scale factor here to be 1/2. And this is our image. This is actually our pentagon here, or pentagon. Now, in this case, guys, on the bottom, it is asking us to find the segment C prime, D prime. So they want us to find C prime, D prime. Now, whenever we do the dilation in this case, guys, it's actually going to be the new image of CD. Now, in this case, if we're going to use the formula here is going to be C prime, D prime over CD equal to our scale factor. So in this case, we actually don't know what C prime, D prime is, so that's actually the unknown. But we do know what CD in this case measures. I'm actually just going to go ahead and count that out. It's 1, 2, 3, 4. So CD in this case equals 4. We also do happen to know our scale factor here. So this is 4, and our scale factor is 1/2. Now, in this case, guys, you could actually see this. One way you could see this is this is actually a proportion here, which means in order for us to solve these two fractions here, we're going to go ahead and multiply across here, or cross multiply here, which means top with top, bottom with bottom on the opposite sides. So in this case, I'm going to go ahead and start off first with C prime, D prime times 2. And that's going to give us 2 C prime, D prime equal to whatever 4 times 1 is, which in this case is a 4. Now, a goal in this case, guys, is to solve for C prime, D prime, so we do need to leave it alone. And in this case, guys, in order for us to leave it alone, we're going to go ahead and divide by 2 on both sides. So in this case, C prime, D prime is going to be 2. So our answer here is 2. All right. So let's go ahead and move on to the next one. And this one is, it says pentagon A prime, B prime, C prime, D prime, E prime is the image of pentagon A, B, C, D, E under a dilation. It says pentagon. So pentagon, in this case, the one that's in blue, is actually the original one. Okay, this is the original one. And the one in pink, in this case, is the small one. Now, notice in this case, guys, how the original one is a lot bigger than the first one, than the second one. So in this case, our scale factor, I forgot to mention this. Our scale factor, if you see that the shape in this case shrinks, your scale factor is actually going to be less than 1. If your scale factor in this case, or if you see that your shape here is actually growing from its original one, then it's going to be greater than 1. But in this case, we're seeing that if we go from this image to this one here, it's shrinking, so that means our scale factor should be less than 1. Now, in this case, guys, we do need to find our scale factor. Now, in order for us to find the scale factor, we're actually going to go ahead and use the segments that are going to be either straight lines. And what I mean by straight lines is that it's either going to be running horizontally or vertically. So we actually have 2 of them. AB runs vertically, and then BC runs horizontally. So I could use actually any of those 2. So let's say I want to go ahead and use AB and A prime B prime. So I have A prime B prime over AB, and that's going to equal our scale factor. So AB in this case, or A prime B prime, is actually 2, and then AB is 1, 2, 3, 4, 5, 6. So this is going to be 2 over 6. Now, in this case, we could actually simplify this fraction to being 1/3. So this here represents our scale factor, 1/3. And I could actually also try it with BC. And in this case, B prime C prime is 1 and BC is 3. So if I were to write this again, it would actually be 1/3. Okay, 1/3. All right, let's go ahead and move on to this next one. And this is actually your practice problem. So you want to go ahead and find the segment AB. So in this case, let me just set up the equation for you. We have A prime B prime over AB equal to our scale factor. Now, 2 of these values we actually already know. So we want to go ahead and find the missing one, which in this case is AB. All right, so go ahead and complete that one on your own. Now, let's go ahead and move on to this one here, guys, which is actually dilating an object. So we want to go ahead and dilate, in this case, an image. So it says, draw an image of a triangle ABC under dilation whose center is P and scale factor is 1/3. Now, in this case, guys, because our scale factor here is 1/3, it means that our shape is actually going to be shrinking. So it's going to shrink. Okay. Now, it is also telling us that our point P represents the center. So in order for us to actually identify the new shape or locate the new shape, we actually want to go ahead and count each point, which means A, B, and C. We want to go ahead and count the distance from all those 3 points from P. Now, whatever we get in this case, we're actually going to go ahead and multiply it by our scale factor. So in this case, let me go ahead and start off first with A in this case. So I want to go ahead and determine, in this case, the distance from A to P. And the distance from there is 1, 2, 3, 4, 5, and 6. It's 6. Now, because our scale factor is 1/3, it means that it's actually going to be shrinking. So if I want to go ahead and find segment, in this case, AP, it's going to be 6, or actually the new segment, let me do that again, A prime and P, we could say, is going to be 6 times my scale factor, which is 1/3. So then that's going to give me 2, which means that my new point in this case, or my new image, is going to be 2 spaces away from my center. But since A in this case is moving to the left, it's actually 2 spaces to the left. So here I should find A prime. That is A prime. All right, now I'm going to go ahead and do the same thing with the other ones. Now, in this case with the other ones, we are going to be moving left and right, up and down. So let's go ahead and see P or B here. And we're actually moving 2 different directions here. Now, going down, we're actually going down 3, and we're actually running 6 to the right. So in order for us to do the new point B prime, we actually have to do this separately. So for this first one here, I'll go ahead and actually change colors there, and let's go ahead and do orange. Let's go ahead and do orange for this one. So that's orange. So for the orange one, I'm actually going to go ahead and do 3 times 1/3, which in this case, that's going to give me a 1. So that means that my new point is actually 1 down from our center. And then 6 times 1/3, which is the one that's in like a hot pink, is going to be now 2. So in this case, our new point B prime is actually going to be 1 down, 2 to the right. So that is B prime. All right, and I'm going to go ahead and repeat that process with C here. In this case, we have down and there. So in this case, we're actually going to the left 3 and going up 6. So in this case, 3 times 1/3, we found it to be 1. And 6 times 1/3 is also 2. So then our new point for C here is going to be 1 to the left now, 1 to the left, and 2 up, because that's where location of C would be. So that is C prime. That is C prime. So let's just go ahead and connect those. And that would be our new image, All right, so in this case, the difficult part, I want to say, or the confusing part, is actually when we do have to do more than one movement, like we did with C and B. So you do have to multiply that out by the scale factor, depending on what you're given. If you're given the original one, you'll multiply it out. If you're given the new one, then you'll have to divide it out. So let's go ahead and take a look at this next one. And in this case, we want to go ahead and draw the image of triangle ABC under dilation of whose center is P and scale factor is 3. So our scale factor in this case, guys, is 3, which means that once again, we're going to go ahead and count the distance. Now, because my scale factor here is 3, it means that our equation in this case, not equation, but our shape is actually going to be growing 3 times the amount it originally was. So for example here, A to P, it's actually 4 units. So my new point, in this case A prime, should be 3 times as big as this amount. So basically A prime would be 4 times my scale factor, which is 12. So it should be 12 units long. So let's go ahead and do that here. And from P, so that's 4. And then 1, 2, 3, 4. Here's another 4. And then 1, 2, 3, 4 is another one there. All right, so then A prime should be here. That is A prime. So that's 12 units in total. All right, so I'm going to go ahead and repeat the same thing with B here. B in this case is 3 spaces away, so then B prime is 3 times my scale factor, which is in total a 9. So from P, let's go ahead and count 9 spaces down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my new point is here, and that is B prime. Now, in this case for C, guys, actually C here lines up with A, and it also lines up with B. So I'm actually just going to go ahead and see here where they line up to find our p-value. And we found that to be right there. That is C, C prime. Or we could also check the distance once again, guys. It's going down 3, right 4. So then that means I have to repeat that process 3 times in total from P. So then this is already 1. We already did that. So let's go ahead and come down 3 again, and then run 4, come down 3 again, and run 4. So that's where our location is. So let's just go ahead and connect these. And that there would be our new image. Our new image. All right, so let's go ahead and take a look at this last one, guys. And then this last one, we actually want to go ahead and see which one of these images actually represents the dilation we want. So in this case, it says triangle A prime, B prime, C prime is the image of triangle ABC under a dilation whose center is P and scale factor is 4/3. Now, first thing you want to go ahead and check with this one, guys, is your scale factor. And the question for you here is the scale factor greater or smaller than 1? And for us, thankfully, it's actually greater. It's greater than 1, which means that your image, new image, should actually be slightly bigger than the original one. Now, notice in this case, guys, that there's no side or no segment of the original triangle, the one that's dashed here in blue. None of them are actually at the center. So it is not touching the center, which means that all of our sides should be moving. All right. So we're going to go ahead and do a little bit of process elimination here. And in this case, automatically, I could actually cancel out D here, because in this case, we said we were growing. Our original one here is the one that's dashed in blue, and the new image is actually smaller than that. So I'm actually going to go ahead and cancel that one out because it is smaller. Now, like I said, guys, the center does not touch any of our lines here. Well, that being said, each side should be growing. So in this case, I could actually also cancel out B, because if you notice here, we have the one in orange, or the one that I'm highlighting over here in pink or purple. It's on the same line as a dashed, which means in this case that's not true, because everything should be moving. Same thing in this case, guys, on C, because they're both on top. There's 2 segments or 2 sides in this case that are also on top of our dashed line. So that one would be out as well. So our actual answer here would be A.